Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video guys, I'll be tackling the fifth question from the mid-year examination, which was written in the province of Gauteng in the year of 2024. Please do expect a total number of 9 videos, since the question paper had 9 questions in total. That simply means each and every question will have its own video. And guys, please do take this seriously. I strongly believe that knowing how to tackle exam questions will give you an edge whenever you write your mid-year exam, your preliminary exam, and most importantly, your final examination. So please do share the video to your peers so that they may have the same edge as you. And please guys, do help us grow the channel by just subscribing. Okay, we are told that a wrecking ball is used to demolish an old building by smashing into it. The wrecking ball has a mass of 950 kg and is suspended in the air with a second rope, which is 3.5 meters above the ground. The ball is then released to smash the building. At the lowest point of the swing, the ball is at the height of H, which is just 1 meter above the ground. Ignore the effects of air friction. Okay, there's no applied force, guys, on the wrecking ball, and we must ignore the effects of air friction. This simply means that, guys, there are no non-conservative forces, and please note that in the absence of non-conservative forces, mechanical energy is always conserved. Are you together? In the absence of non-conservative forces, mechanical energy is always conserved. Now, okay, first question. They want us to state the law of conservation of mechanical energy. It simply states that in an isolated system, mechanical energy is conserved. Or you can say in a closed system, mechanical energy is conserved. Now they want us to okay, 5.1.2 rather. The ball swings and hits the hits the building at height H. Calculate the speed with which the ball hits the building using only energy principles. Since, guys, we know that mechanical energy is conserved, we can therefore conclude that the mechanical energy of our ball before is equal to the mechanical energy of our ball whenever it hits the building. Now, initially the ball was at rest, and then finally the wrecking ball hits the building. So mechanical energy, guys, by definition is just the sum of potential energy plus kinetic energy initial, and then potential energy final plus kinetic energy final. So all you have to do, guys, is to just substitute now. Okay, the mass of the wrecking ball is 950. The gravitational acceleration is 9.8. The height of the ball initially was 3.5 meters, right? The height was just 3.5 meters. Plus the kinetic energy, guys. Initially the ball was released from rest. That means the initial velocity of the wrecking ball was 0 meters per second, and if the velocity is 0 meters per second, it simply means that the kinetic energy will also be equal to 0 joules. Initially the kinetic energy was just equal to 0 joules, and then the potential energy when the wrecking ball hits the building, it's simply 950 multiplied by 9.8 multiplied by the height above the ground, plus 1 multiplied by 950 multiplied by the velocity with which the wrecking ball hits the ground at. Now, all you have to do now, guys, is to just simplify this thing over here. On the left hand side, I'll just have 950 multiplied by 9.8 multiplied by 3.5, and this will just give me 32,585. 32,585, and then over there this will just give me 9,310 plus 950 divided by 2. 950 divided by 2 plus 475 times v squared, right? So if I take the 9,310 on the other side, I'll end up having 32,558 minus 910 9,310. This will just give me 23,275. I have 475 times v squared. Therefore, v is just the square root of 23275 all over 475. 23275. Ah man, the square root of 23275 divided by 475. And then our final velocity is just 7 meters per second. The velocity with which the wrecking ball hits the building is just 7 meters per second. It's just 7 meters per second. And then now we are told that the ball hits the wall and it takes 0.1 seconds to stop and then rebounds. They want us to calculate the magnitude of the force with which the ball hits the wall. Whenever, guys, there's a collision, please, guys, do not forget momentum and impulse. Okay, I know that F net delta t is equal to the change in momentum. That means, F net is basically equal to the change in momentum, Vf minus Vi all over the change in time. The mass of the wrecking ball is just 950 kg. The final velocity, the ball will stop momentarily, guys, before it rebounds. So the final velocity will be 0, and then the initial velocity is just 7. It will take 0.1 seconds for the ball to stop. So this is just 950 multiplied by 0 minus 7 all over 0.1. I'll simply get negative 66,500 newtons. So the magnitude of the force, guys, is just negative, but they said they wanted magnitude, is 66,500 newtons. Then now they want us to write down the force that the wall will exert on the ball and name and state the law in physics that is used to arrive at this answer. When body A, guys, exerts a force on body B will exert a force will exert an equal but opposite force on body A. So same thing applies here. When the wrecking ball exerts a force on a wall, the wall will also exert an equal but opposite force on the wrecking ball, but in the opposite direction. Are you together? So the magnitude of the force that the wall will exert on the ball is also equal to 66,500 newtons. Are you together? And then they want us to state the law of physics that is used to arrive at this conclusion. It simply states that if body A exerts a force on body B will exert an equal but opposite force on body A. We use Newton's third law, guys, and it states like that. Okay, and then let's go to question 5.2. We are told that a grade 12 learner with a mass of 75 kilograms is on a skateboard with a mass of 2 kilograms, which is moving at a constant velocity of 2 meters per second east over a frictionless surface. A ball of mass 500 grams moving at a speed of v towards the west is thrown at the learner. The learner catches the ball, and then the kinetic energy after collision is 146 joules. Okay, so after the collision, guys, the boy will move while he is having the ball. Are you together? So we can find the velocity of the skateboard boy and ball combination. Because we are told that after collision, their kinetic energy, let's say this will be the mass of the boy plus the mass of the skateboard, since they are moving it as one system, and the mass of the ball multiplied by V. Together, we are told that this is 146, 1 over 2. The mass of the boy is 75 kilograms. The mass of the skateboard is 2 kilograms. The mass of the ball is 0.5 kilograms multiplied by V squared, right? So this will just give us 146. And then on the left hand side, I simply have 1 over 2 multiplied by 75 plus 2 plus 0.5. This is just 38.75 multiplied by V squared. Therefore, V is just the square root of 146 divided by 38.75. The square root of 146 divided by 38.75. Man. Okay, let me just redo this. It's 146 divided by 38.75. And then our answer is just 1.94 meters per second. I can see that, guys, the speed of the ball and the skateboard combination after the boy catches the ball has decreased from 2 meters per second into 1.9 meters per second. Are you together? So now we can find the initial velocity of the ball. How can you do so? By using the conservation of momentum. Né? And we know that the sum of the momentas before collision is equal to the sum of the momentas after collision, right? Before collision, if you're going to call the boy and the skateboard combination A, and then this combination is B, né? So the magnitude of momentum of A plus the magnitude of the momentum of B is equal to MA plus MB multiplied by V. Initially, guys, the boy and the skateboard were moving at 2 meters per second towards the east. Né? Please choose a positive direction. Let's take east as positive. Okay, the mass of the boy and the skateboard is just 75 plus 2 kg. That's equal to 77 kg. And their velocity is positive 2 meters per second plus the mass of the ball, that's 0.5 kg. The velocity, that's what you are looking for. I'm expecting to find a negative velocity, guys, né? Since the ball was thrown to the left, and we said that any movement towards the right or towards the east is positive. Okay, over there I simply have 77 plus 0.5 multiplied by 1.94 right together. So therefore 0.5 multiplied by VB is just equal to, let me punch my calculator, 77 plus 0.5 multiply 77 plus 0.5 multiplied by 1.94 minus 77 times 2. This will simply give me an answer of negative 3.65 meters per second. And if I divide both sides by 0.5, guys, divide by 0.5, answer 3.65 divided by 0.5 divide by 0.5. Then our velocity of the ball, guys, is just negative 7.3 meters per second. Yes, I was expecting to find a negative velocity since the ball was thrown towards the west. So the initial velocity of the ball is just 7.3 meters per second west. That's how, guys, you're supposed to tackle this question over there. So please do stay tuned and wait for more videos. Thank you.